This is a special video about two tools of Terra Antiqua. They are called Create Topo Bathymetry and Modify Topo Bathymetry. There are two other videos dealing with each of them where I show in detail how to use them. If you haven't seen those, there are links in the description. In this video, I will explain how to use both tools combined. First, I will briefly describe the tools, then I'll present a real case scenario and we will see the best choice for each region that needs to be edited. I will run the tools to do a succession of modifications and you will see the final result. This video is part of the playlist on primary tools. In the Terra Antiqua YouTube channel, you can find videos for every tool. They are also accessible from the manual. Create Topo Bathymetry and Modify Topo Bathymetry are primary tools. This means they are part of the main reconstruction workflow. Both are meant to edit the topography and bathymetry in given areas that you have to define. Then, these tools allow you to concentrate on those areas of interest and edit the local topography or bathymetry with precision. The order in which you use these tools is up to you. As you see in this diagram, they represent the final step of the main workflow. In this video, I will suggest the methodology that we found to be most effective, but Terra Antiqua is a very flexible plugin, so feel free to find your own way. Here you can find a reference to using modified topo bathymetry several times, which we are going to do now. If you have any feedback on these methods, you find other ways to use these tools, or find issues in the functions, you can use this form to let us know. We answer every request that we receive. The idea is to run the tools successively. The output of the first run being the input of the second, the output of the second being the input of the third, and so on. To see how each of these tools works in detail with step-by-step indications, the link to both videos are in the description and in the manual, in their corresponding pages. Here I'm using the data from the sample data bundle for a global 30 MA reconstruction. According to the literature, these regions were not too different back then. They were steeper or flatter, higher or lower, but they existed and had similar shapes to the present day, which means they just need to be rescaled so we can keep the original pattern of elevation. We want to keep the natural pattern as much as we can because it is, for now, the best way we have to keep realistic topography. For this, we will use modified topo bathymetry. The data also tell us that these continents had much lower elevations. The best way to deal with this is first to lower the elevation of the large areas. The final minimum and maximum elevations are in the attribute table. Then we can work on the smaller areas. The approach that is behind Terra Antiqua is to assume that we can reconstruct the past by modifying the present-day geography, and that is what we try to do as much as possible. However, some features have to be completely redrawn. In fact, when the region we want to reconstruct was too different from its present-day equivalent, or maybe doesn't even have an equivalent, we use Create Topo Bathymetry. Now you see that all those areas have been linearly rescaled between the new minimum and maximum elevation values. Now we can run the tool a second time for a detailed rescaling in the smaller regions. Although it looks like they disappeared, the elevation values for those regions were just linearly rescaled, but the original pattern is still there, and if we define a new minimum and maximum values, they will grow back to the elevations we want, keeping the realistic aspect of the present-day geography. This is the result for these regions that have been just rescaled. It's not the case in this reconstruction because we used the standard linear rescaling, but if you have regions where you want to modify the elevation with a custom formula, this would be the best time to do it, running the tool a third time using this map as an input so that you can keep building upon it. Now let's move to those regions that change too much and where we need to generate topography from scratch. We will do the High Andes, Ethiopia, and Tibet in this example. Let's run the tool. Since our three polygons are on different layers, we'll have to run the tool several times, like we did with modified topo bathymetry. The parameters you have to enter are completely up to you. Some of these files have values for elevation in their attribute tables, but Ethiopia, for example, doesn't. You should try several combinations based on the data you have until you get the result you want. Here I'm using the data from the exercise Get to Know Terra Antiqua. The link is in the description. The Central Andes are too complex to reconstruct by simply modifying modern topography. Because a very complex model was used in G-plates for these reconstructions, the Central Andes are represented with dozens of small tectonic blocks that were independently rotated back to the 30 MA position, making this part of the Andes much wider than it used to be. Following the redefinition of the shoreline and the subsequent interpolation, the gaps between the Andean blocks have been filled, and the result looks like a broad, low elevation plateau. After checking a large body of literature, it turns out that the Andes were already quite high 30 million years ago, but only within a narrow band with low elevations on each side. This is why this part has been left out of the previous step. To do this, we will reshape the area defined by the High Andes shapefile using the tool Create Topo Bathymetry. The reason why we are using this tool to reconstruct the Ethiopian volcanic region is similar. The Red Sea, the Gulf of Aden, and the Rift Valley, which shape that part of the world today, looked too different 30 million years ago, making a simple rescaling impossible. That is why we have to use Create Topo Bathymetry. Tibet is one of the most complex regions to reconstruct in the Paleogene. I won't go into detail, but the problem is similar to the Andes. The shape Tibet had is too different from what we have on the map at this point, so we have to generate topography from scratch. For the Proto-Tibet Plateau, the tool modified topobathymetry could be used, but now we need to create a high elevation linear feature within it. This is the map at the end of the main reconstruction process, once you have used all four primary tools. There are other polygons for you to try out different configurations to create topography or bathymetry. Now that the reconstruction itself is finished, you can go to the enhancement part, which is done with the secondary tools. There are videos for them in our YouTube channel and in the manual.